Hey, Joe here again. In this lesson, you've learned about how to use logic to allow your program to make decisions. However, this can be challenging to debug, as errors in the logic don't always come with helpful messages. That's why, in this video, we're going to explore a useful debugging tool named Python Tutor. Initially designed for Python, it has since expanded to support JavaScript and several other languages. As we're using the JavaScript feature, we'll refer to it as JavaScript Tutor. First, let's have a look at what we want our code to do. The function we have already written for you is a gift generator. If the recipient is anyone but Charlie, they'll get an age-appropriate gift. Any child under 5 years of age will receive a soft toy. If they are 5 or older but less than 12, they'll get a fiction book to stimulate their love of reading. Adolescents of 12 or older will receive a new mobile phone, and anyone else should get some money to buy whatever they like. If the recipient is Charlie, however, we have something special in mind. Charlie will get a bar of chocolate with a golden ticket to Willy Wonka's chocolate factory. Regardless of what gift they get, the output in the console should greet the recipient by name, tell them what their gift is, and that we hope they like it. Usually, you will write your code in an IDE, and when you encounter bugs, you would then copy your code and paste it into JavaScript Tutor to help you fix it. So to get us started, we've provided you with some code below this video. However, it still contains some bugs we need to fix. We'll use JavaScript Tutor to help us. Below this video, you'll find the code block. Please copy the code from there, and then click on the JavaScript Tutor link provided just beneath the code block. This way, you can easily follow along with me. We'll start by pasting the code into the editor that appears. Then, we need to click on Visualize Execution. The first thing we can see is that we get a message in red telling us there is an error here, and a red box with a white cross on line 6. You may already be familiar with this type of error, as it looks the same in the runnables you've been using. It represents a syntax error. As you already know, when we use a condition after an else, we always need to have the if keyword as well. This was left out on line 6, so let's add that in. Then, let's see if it runs now by clicking Visualize Execution again. Great. Now that there are no more syntax errors, the code is running in the visualizer. This pop-up message box here has the details of the error we just fixed. We don't need that anymore, so we can close it and have a look at the rest of the page. JavaScript Tutor indicates that there is a function named giftGenerator within the global frame. In JavaScript Tutor, the global frame simulates the global scope. There are 8 steps in the code, as shown here. The red arrow indicates that the first line in our code that will run is line 19, where the gift generator function is called for 3-year-old Jill. For each of these function calls, we've added a comment indicating the expected gift. Jill should get a soft toy. First, let's run the code in full to see whether that's working correctly. To do this, click Last to fast forward to the final step. The arrow in front of the console log on line 19 has changed to light green, indicating that this was the last line of code to run. In the print output box, we can now see the string output. But that doesn't look right. It's not greeting Jill. It starts with name in curly braces. So what happened here? The biggest benefit of JavaScript Tutor is that we can use it to walk through our code to find the problem. So let's go back to the code and step through it from the start. Click First to go back. Now the arrow on line 19 is the red one again, as it will be the first line to execute. We'll click Next to run that line. Now the arrow on line 19 is light green again, as the function has just been called, and the next line of code that we'll execute is line 2. Now that we've called the function, let's have a look at the visualizer on the right. There's a light blue box here telling us we are in the gift generator function's scope, that the name parameter is set to Jill, and age is set to 3. There's also a variable called gift but as yet this is not defined. So far so good, so let's keep going. We'll click Next again, and now we can see that gift has a string value, gift description, in the light blue box. The light green arrow is now on the line that just ran, setting the value of gift, and the red arrow indicates that the next line that will run is the if statement. As Jill is not equal to Charlie, we expect the condition to evaluate to true here, so the if statement should run. Let's click Next again to see if that works correctly. Great, it does. So now the inner if statement is the next line that will run. As 3 is less than 5, we expect the first condition to run correctly, so we'll click Next again to confirm that. Yes, it does, and the next line to run will set the gift to a soft toy, just as we want it for any child under 5 years old. When we click Next again, we can see that the value of the gift variable is updated to a soft toy. So that means the if statement is working correctly for this function. The next line to run is the return statement on line 16. Let's see if that's working correctly then. Oh, now the return value in our blue box is showing, name, your gift is a soft toy. Hope you like it. So this is where our bug was hidden then. Let's have a look at the return statement in the code then to see what happened there. As you can see, we've inserted 2 variables, name and gift, into this string. While both variables have the correct values in the frame here, only gift is coming through correctly in our string, but name is not. The curly braces are present on both variables. Oh, we missed the $sign syntax on the name variable. To add that, we first need to go back to the editor with the edit this code link below the code block. Here, we can add the $sign and then click Visualize Execution again. Now, let's click Last again to see if that worked. Awesome, that fixed the name issue. The output is now correct. So now we have corrected the code and the first function call works correctly. Let's test to see whether the next part of our code is working. To do this, we'll need to click Edit this code again. In the editor, we can now comment out that first function call and remove the forward slashes on the next line. We'll click Visualize Execution again. The red arrow now indicates that the line that logs 11-year-old Bob's gift will be the next to run. As we can see in the comments, Bob should get a fiction book. Let's click Last again to see if that's working correctly. That's not what we expected. It shows that Bob's gift is some money to buy whatever he likes. So what happened here then? Let's go back with first again so we can step through the code. When we click Next the first time, we can see on the right-hand side that our gift generator scope appears again. This time the name parameter is set to Bob, and the age parameter has a value of 11. The gift variable is again undefined. As before, we can see in the code block on the left-hand side, the red arrow has moved to line 2, indicating that this line will be the next to run. Where the red arrow used to be, on the function call, there's now a faded green arrow, indicating that this line of code has executed. So we know we are now in the function. Let's click Next again. As with the previous function, the function scope now shows that the value of gift is set to gift description. The green arrow is now at line 2, and the next line to execute is the if statement, if name is not equal to Charlie. As Bob is not equal to Charlie, this line should run without issues too. Try to predict what will happen next. Where will the red arrow appear? What about the green arrow? Have you figured it out? Let's click Next again to see whether you were correct. Did you predict that the red arrow would move to the first line of the nested if-else statement, and that the green arrow would show on the outer if statement? Well done if you did. Let's do that again. Pause the video to try and predict what will happen, and come back when you're ready to see if you were correct. Welcome back. As age is 11, which is greater than 5, the first condition returns false. The red arrow then moves to the second condition. Will this run? Let's find out by clicking Next again. That one is skipped over too. But according to our slide, we wanted this to run so that Bob would get a fiction book. Oh, our condition says greater than 12 instead of less than. So let's edit the code to fix that. We'll go back to the code editor with Edit This Code. According to the description, any child of 5 or older, but less than 12, should receive a book. So let's fix the condition on line 6 to match that. Then let's visualize it again and click Last to confirm whether that worked. The print output box now shows the text, "Bob, your gift is a fiction book. Hope you like it." Just as we planned. Great, we've debugged another error. Are you seeing how powerful a helper JavaScript Tutor can be yet? Now it's your turn. I'll leave our expected logic up to help you, but this time you're holding the reins. Comment out line 20 and uncomment each of the remaining console logs in turn. Step through the code and try to predict what should happen and what will happen, and fix any errors you find. Take around 10 minutes to try that. When you're ready, come back here and we'll go over them together. I'll see you in a bit. Welcome back. How did you get on? If you followed along with the same process, hopefully you found 2 more errors in the code. 15-year-old Jane got money instead of a new mobile phone, as we had another error in the comparison with greater than where it should have been less than, and Charlie got a mobile phone, as Charlie with a capital C is not the same as Charlie with a lowercase c. Updating the string in the outer if statement's condition fixed that. The function call for min, whose age we don't know, did work correctly, so we didn't have to fix anything there. If we now visualize the code one more time with all our function calls uncommented, and click Last again to see the final output, we can see that our output matches the expected logic as we wrote it in the slide. Well done. It's best to use JavaScript Tutor if a bit of code isn't working as you expect, or even if you just want to understand the flow of the logic better. JavaScript Tutor also works best for a specific part of the code to see what's happening. It does have some limitations, however. You shouldn't load an entire project into the editor here, as there may be too many steps needed for JavaScript Tutor to run it. Use this tool when you feel you need to break a bit of code down into steps, so you can better understand what's happening at each step. And that's it for this video. Now you know how to use JavaScript Tutor. You've got another tool in your debugging toolbox alongside simply logging to the console. Remember to bookmark the link so you can easily find it again, as you may find it useful in the next lesson too when we start working on iteration.